Okay, hello everybody. Welcome to lesson 7 that we're having. Yeah, it is 7. Okay, I'm gonna start this event. Yeah, back to school. Exactly. Okay, I'm gonna start sharing my screen before I forget it because I have done that unfortunately a few times so far. So yeah, let's not let that happen now. Okay, uh, so here are the things that we're gonna do today. As usual, I'm gonna get them out here. Sorry, I barely have my voice because I've been holding private lessons today, like pretty much all day, and like yeah, I'm starting to lose my voice for the day, but I'm gonna hydrate a bit and it will get better probably. And welcome guys in the meanwhile, and hello everybody who's watching the VOD or the YouTube video. Yeah, I have recording going, so we should be all good. Just look at all these goddamn projects. There's just so much, and they keep piling up. Yeah, okay. So this is where we were in the video. If you haven't watched the video, then make sure to go to the YouTube channel. Also have a little archive here, and you can just reach the latest lesson right away. Well, we got some more subs. Oh, they nice, kind comment. Okay, nice. I'm really happy to see these kind of like messages, and also that the sub count is basically increasing without me doing virtually anything, like besides these videos. So yeah, I'm really glad. Okay, so let's actually get into the topics we have here. So this lesson is mostly about navigation and pathfinding, and also some physics related things. But yeah, it's mostly navigation. So let's start off with that. In 2D, luckily we only have two axes to worry about when it comes to pathfinding, and Godot has a couple of nodes to do that. So pathfinding is when you want an object to go to another object, while also like considering potential obstacles and all those things that may be in your way. So one pretty cool node we have is Path2D, and this allows us to basically create a path for our character. And yeah, we can just define these paths. Apparently we cannot like add to them by just clicking somewhere. Although we can like curve the path in a way so that it's not like completely straight. So we can use this, and then if you look into the documentation, like here, you can get the curve, and like you can set up a system which keeps retrieving the points of the curve so that your object will keep following the path. But then we have something else called path follow 2D. And this actually gives us an error. So path follow 2D only works when set as a child of a path 2D node. So if we drag it like this, now you can see basically we have this progress here that we can make, and the progress ratio. So the ratio is the value between 0 and 1, where 1 marks the end of the path. So this can actually be used to like travel a certain path. And then if I, set one of our sprites as the yeah, let's set this one. If I set one of our sprites as the child of that path follow, then basically if I just keep increasing this value, our character will kind of move. And it also rotates, but we can't disable that here, I think. Now it stayed rotated because, the changes got applied. And also the, yeah, that one. Oh. Wait, we are still, oh, right. Yeah, okay, that's what we were looking for. Yeah, because the rotation gets applied to the path follow to the... Okay, so if we do this, you can see we are not rotating now. And we can actually traverse through the path by script. So I'm going to create a new script called let's call it my path follow 2D for the sake of creativity. Just like that. And this is where our other topic comes in, the tween node. And basically tweens let you adjust a variable under a certain amount of time to reach so that it reaches the destination value. So you create a tween similarly to timers. You do get 3 dot create tween, and we can store this as our tween. And then we have in tween we have a property called or a function called tween property. And basically you need to pass it the object, this property you want to adjust, and then the property name, which in our case is progress ratio, and then the final value called as final val. So I want this to be 1.0, and we also need to assign the duration. So we could make this like 2 seconds. And something pretty useful that I haven't shown you guys yet in this course, I think, is if you hold Control, you'll be able to... So you can see that some things are underlined that are either defined or their functions, classes, whatever. So if you hold Control and press left click on the mouse, you will see that it takes you to the function definition. Same goes for a Radiant process. It takes you to the proper place. And the same is the true for classes. So yeah. And now let's run this and see what happens. You can see we made the path. It was a bit rough because we are taking too long of a distance in that period of time, but yeah. This is basically how you use a path. We also have something called navigation agent, which is typically also used for pathfinding, and this also has avoidance, as you can see, and we have these avoidance layers here. So you would want to set that to enabled if you have any obstacles in the way. And then you have the pathfinding settings over here. And in the documentation you can also see the methods to calculate or set your path. You actually need to set the target position variable of the navigation agent, and that is what it will move towards. I think I can just make this script here, and if I say that the target position is, let's say it's like the end of this path, so we'll need to get the node, right? Path to the, and then get its curve variable, and it has this points array. And then we can use the back method of an array to get the latest element. However, if we look at this, yeah, curve. Oh, yeah, right. Yeah, so this is not a simple array because it has this position and the out, position in and out. So this can also create a little curve here. You can see we can technically make curves with this if we like specify the in and out coordinates. So what we need to do is that we get the, where's, yeah, get, we should use get point position. And then the index would be, this is going to be a long line. It would be point count, something like that. Yeah, that's the property. I wonder if this works out. Oh, and yeah, like we won't know because navigation agent doesn't have a visual thing assigned. So we can just add the player probably. But I'm not sure if we'll be able, yeah, we should be able to see any motion. Oh yeah, point count -1, sorry. Okay, now we get no arrows. However, we are still not doing the pathfinding because I assume we would also do the tweening we've just done here, and I'll probably repeat that because you know we can use a tweens finish signal, so like it will be a loop in a way if you want to like go through the path using a navigation agent. But yeah, typically this path is pretty good as well for just traversing a certain path. And there are other things, like if you're working in a grid, there's A star 2D and A star grid 2D. These are also like pathfinding algorithm classes. They are implementations of the A star algorithm, and you can play around with these as well to just you know, you do pathfinding on a grid without having to write the algorithm yourself, even though it's a good coding experience. So I recommend doing that for the sake of learning something. If you just look up a star algorithm, you can find a lot of resources and even pseudocode on implementing it. Okay. And then the next thing we will be talking about is the motion with physics. So in the last lesson, in the video format, we looked at some of these physics body types, and it's important to know that they have particular functions to move considering physics. Well, actually, it's only it's rather rigid body that runs in actual physics simulation, but character body has the capabilities to do that. As you can see, we've added this boilerplate code. So in character body, it's move and slide that handles basically the collision part of the motion, and it moves the body based on the velocity property it has. So yeah, you can give this a read. And so yeah, this is different from just simply doing position plus equals velocity, of course. Because if I try to do that, see, like, to begin with, we have like literally just disappeared so quickly. Basically fall through the ground, but with move and slide that is taken into consideration. And we can move. So yeah. Oh, and yeah, from the last time we have the collision layers also set to something else. So to be able to collide, let's do it like this. I'm also gonna remove the raycasts. Okay, there we go. And if you want to move a rigid body, there's just plenty of documentation on it. There are a lot of forces that you can play around with, and I can actually show you. I'm gonna create a script for this one as well. My rigid body. And let's say like 2 seconds after starting, we are gonna apply the center of force of like vector 2 that's right, and let's see what that does to us. Well, it doesn't do anything. So why could that be, right? Even though we get here, so it applies the directional force without affecting rotation. Maybe the force is too small to have an effect. I guess you can see if we make it super huge. No, it's actually not that. In this case, well, we can, always try and debug it. Try figuring it out. You can see the velocity actually grows. It's actually really, small. So if I increase this by a bit, you can see that we are moving. So I'm thinking this is still just too little of a force to like have an actual effect. Oh yeah, see, now we are moving. Pretty slowly, but we are moving. And you can also choose where you apply the force. Because as the documentation said, this is basically the equivalent to using your apply impulse. Or, sorry, wait. Where is the apply center of force? Yeah, equivalent of using apply force at the body's center of mass. Oh yeah. Yeah, this video is really good actually. Everyone should watch it. Freya makes really great math videos. That's a really good one. I can recommend it. And she also made, so
Before
all the stuff.
their roots.
If I'm not mistaken, she's made all of these like diagrams and all the animations in Unity using her own plugin. So that's also really impressive. Okay, and then we have this thing called apply impulse. And if we do this, you can see it gives us more momentum. It is much faster. And the impulse is also time independent. And if you want to force, I think the setting of the position of a rigid body to like kind of overwrite the physics aspect. There's integrate forces. It's this function. Yeah, exactly. All right. So what's pretty much left is sine and cosine that I wanted to talk about, and they're rather used in shaders, but we can also apply them here. So I'm just gonna take the sprite and create a script, sine cosine sprite, and then we will need the starting position. Let's start pause. It's gonna be position. And I'm gonna say that position equals start pause plus like, let's do the sine of time dot get x msec. Let's see if this works and let's see what happens. Oh, right. Let's do that to the x. You can see we are kind of vibrating. So if I multiply that, now we're basically moving pretty quickly. And we can try this simulation. I'm gonna try to kind of slow this down. Yeah, okay. That's much nicer. Yeah, okay. Let's try and do this on the y coordinates as well and see what happens. So we're kind of moving in a diagonal direction, right? So sine and cosine typically they are used for like repetitive and also circular motion. We can also try just setting the scale of something to be this in a vector. Yeah, this is also right, yeah. Thanks for highlighting that. This is also really important. So we have the thing called, oops, we have the function called, where is it? Physics process, and yeah, so this executes at a constant frame rate, but that frame rate can be set in physics common and physics ticks per second. So if I set this to 1, you're gonna see that the rigid body that was falling before, oh, don't mind that, it hasn't fallen off yet. And then the impulse took effect, of course. Okay, let me deal with the sprite first. We could do something like 0.1. Yeah. You can see that we like the sprite keeps like going upside down, and that is because you know, this can be also a negative value that sign returns, because it moves between 1 and -1 on the y-axis, and that's the value we are basically getting based on what our input is. And you know, this curve is repetitive, so it keeps repeating itself. And yeah, there are just a bunch of cool motions that we can do using sine. And there's also like cosine, which, you know, the different curve. It's basically the same as sine if you think about it, but its cycle has an offset compared to the one that sine has. And now if you do this basically creates a circular motion. You can see how we're moving in a circle, sort of. So yeah, that's what you can do with sine and cosine, and if you're more interested in math stuff, then you should check out Freya's channel, because she has a bunch of pretty cool math videos, and also like math courses that she sold. There's also sine and cosine,
So you want this direction, right?
this
Like as a vector.
visual representation.
And if you want the
And yeah, there are some really nice videos to give you an idea. I can also link it here. And I think that's all we had to cover today. So yeah, I think that's pretty much it for this week's lesson. And next time, I always forget where I put the schedule. Yeah. Next time we're gonna be doing some interesting audio stuff, and also just messing around in the inspector. So yeah, that's what we're doing next, and we are actually approaching pretty rapidly to the end of the course. Like, we are basically more than halfway through now. So thank you guys for joining, and I'll see you next week. Goodbye.